We're good.
We're good? All right. Okay, hi everyone. My name is Mike Brash. I work for Extreme Networks. Everything I'm going to say here are my own opinions. I spent a lot of time thinking about defensive technologies, and that's perhaps not as interesting to some of you, but it's certainly important. I think there's a lot of room for improvement in that area, as we all probably know. So this talk fundamentally is about how to improve, I think, the Snort signature language, and I'm not going to get into the signature versus rule debate here, but the Snort signature language for a particular style of app delivery. And in particular, just a quick primer on flowbits. The flowbits keyword in Snort's language is, I think, a very powerful keyword. It allows you to essentially take a set of signatures and have them work together as a group in order to try to more effectively detect certain kinds of network traffic, malicious activity, or other things you may be interested in. So at the bottom here are two Snort rules that are designed to show you that you can, with an IMAP communications, if you're interested in, let's say, the IMAP list command, but you only want that rule to fire if you previously had seen a successful login from the same TCP connection. So these two rules show you that you can bidirectionally have flowbits criteria apply to both sides of the connection. That's great. Another good example, not listed here, is if you have a condition with a vulnerable service that for which the trigger condition is triggered very early on in the TCP connection, say you're able to trigger a user after a kind of problem. But then if the attacker is able to control how much data is then transferred after that condition is triggered, before then a follow-on usage of that problem is then done, then it can be very difficult for Snort to be able to track that, because if you have, let's say, 100 megabytes worth of data between the two things, then in the absence of flowbits, Snort would not do very much good there. But flowbits saves you in that case, because you can set a flowbit on the first criteria, and then just test it arbitrarily deep in that TCP connection for the follow-on condition that you're trying to trigger. Very powerful. However, there is one very significant limitation in flowbits, which is that you cannot have flowbits applying across multiple TCP conversations, or I should say transport layer conversations here, because UDP is also available. So I can't set a flowbit on one TCP connection and then test it within a separate, totally separate connection. But does this matter? So put another way, if there were to be an extension of flowbits, or perhaps a new keyword that gives you the ability to set a bit on one connection and test it within a separate connection, would you gain a benefit in terms of attack detection, better attack detection? So a way to approximate an answer to that question is look for Metasploit modules for which reliable exploitation requires multiple conversations. So a good first pass is to look for TCP connect calls. The TCP connect UDP is the UDP version of that UDP traffic, and send requests to GNI ports or access web servers, but behind the scenes it's also using a TCP connect call. Quick approximation, searching through the Metasploit Git repository. This gives you some evidence that there are many actually, hundreds of Metasploit modules that do appear to require multiple TCP connect calls. It requires a little bit further validation, because you might have certain connect calls that are listed, but they're wrapped with if statements or something, so they don't get actually always called when you try to exploit something. But at least through some additional work, you can. It is certainly true that many of them do actually use multiple calls. So a good example of one, and I wrote a blog post about this a few months ago, the ContentKeeper web application versions prior to 125.10 is vulnerable, contains a vulnerability that has a very reliable way of exploitation through Metasploit. The particular way in which this vulnerability is exploited requires two independent TCP conversations. Now, I'm not going to get into the HTTP persistence ideas here, because that may apply too, but the point is the Metasploit code itself is implemented in a way that uploads a basic encoded Perl script to this mining code CGI application, which is sort of the entry point to the vulnerability. And this spamkeeper.dat is a file that is influenceable by the attacker, and that's where the basic encoded Perl script is uploaded, and then is executed via a follow-on HTTP GET call. So even independently of the Metasploit check function, which looks for a violent internal error from that same mining code script, even in the absence of that, reliable exploitation requires two TCP conversations. There are other examples as well. The SCADA technology, IDS rename overflows is one that you might be interested in. And this Apache IS API DOS exposes a user after precondition in the mod IS API module that, again, requires two independent conversations. For that last one, an aborted call creates this user after precondition, which is then exported in a subsequent connection. There are certain more like this. So the part of this talk is a proposal for a new keyword, and if I have time to go into some of the trade-offs, I suppose, but I think it needs to be a new keyword because backward compatibility is certainly important. Changing the model through which flowbits operates just by extending flowbits itself might create some issues. But xbits for crossing the streams. So the idea fundamentally is to be able to set an xbit on one TCP or transport layer conversation and test it within a totally separate conversation, whether or not the first one has closed or not. Underlying semantics or modifiers to xbits would be the same as flowbits. So in particular, set, unset, no alert, etc. would all be the same. But there need to be two additional modifiers at least. One where you'd be able to track by IP pair or destination port or any other sort of TCP IP tuple combination that you would like. And then also expire. Because if you remember the ContentKeeper instance we just talked about, the act of uploading the base64 encoded Perl script, that TCP conversation is going to close and then is executed in the follow-on connection, which means that if we're going to track traffic in this way, the xbit that we set on the first connection needs to remain resident even after the first connection is closed. But we don't want them to remain around forever when Snort's process address space or sort out everything else in Snort style signature language. So we need to have a way of expiring those xbits over time. This is an example of what the Snort rules would actually look like that would track this style of communication for the ContentKeeper exploit. I have an example of this on my website. I certainly can't write them all out here on this slide, but the fundamental idea is to set the xbit on the payload upload and then track to see whether or not that payload has been actually executed after the upload is successful. So, of course, there are a lot of trade-offs because you might say, well, just write a Snort rule that looks for this mining code with this funny-looking sort of permissions-ish sort of stuff that's sort of the entry point into the vulnerability. That's fine. There's no reason why you can't also do that underneath the xbits model. But if you do get an alert for traffic like this, what's the first thing you're going to do as a security analyst? Well, your next natural question is, was what they uploaded actually then executed? Which means that you're going to have to do the same kind of thing that xbits could have done for you within the Snort's language. So why not promote that concept into the language itself? You could also imagine architectures where maybe you could implement this today within shared object rules or something like that. That's fine. But it is my belief that this style of intrusion detection is important enough to promote it into the core language itself via There are certainly performance implications that may affect proper operations. Some IDSs are multi-threaded, like for example, server hot is multi-threaded, so you're going to have issues with respect to threads not having the global view of all traffic, perhaps. And you have the same thing with the Snort world too, where you have multiple Snort processes that are being fed data and split by network processors or gigamon taps or other kinds of architectures. So, nevertheless, I think that if you think a little bit more broadly even than this, applications these days themselves have long since thrown by the wayside just individual communications. You have lots and lots of things that happen. Think about anything that uses a signaling protocol. FTP's done this for decades. You have DNS requests, you have BitTorrent, things like this that are by design using multiple conversations to transmit data, share information, etc. It therefore is a corollary to that the attacks will over time too. And I believe that the Metasploit project provides kind of a roadmap for seeing how that will be done over time. So, in the SIM world, I believe that part of the SIM vendor's success, in some sense, it can be tracked to the fact that they have a style of detection that's very similar to this by design. They don't care that you get a failed login alert from one piece of infrastructure with a Snort alert from something else. They are doing this sort of correlation by design. I think that there's room for the network IDS community to also do some similar style of essentially correlation across transport layer conversations directly within the language. So, writing a second edition of my Linux Firewalls book, I tend to cover xbits here. Within this second edition, I would love it if you have feedback for me on this, or if you have any questions about it. We actually require about those times for questions. Questions, please. Yes.
So, what is next for xbits? Convincing Snort developers to, take a whack at an implementation? Are you trying to do one that you can plug in and see how it works?
The question was, what's next for xbits? Is there a development effort started yet? I talked a little bit with the Suricata guys, and it sounds like that they may start moving in some direction similar to this. Whether or not it actually becomes xbits here, I'm not sure, but I think that they probably agree with the core idea. The Snort community, I'm not really sure. We'll see. Anything else? Yes?
So you pointed out, talking about vectors that require multiple connections or conversations, but really it's any exploit that can be split up to try and bypass conventional IDS definitions. It's more of a concept question.
Yes, so I think your comment is that this will apply to any exploit that can be split across multiple conversations. Is that accurate? Right,
opposed to one which have to be by their nature, yes.
Yes, so absolutely. I think that, I would agree with that statement. I'm not sure if typical IDS evasions, I would say, kind of, with respect to TCP, have always played in the send and attack right at the time, and spoof forward TCP packets to contain traffic that matches the secret set and stuff like that. I haven't seen so many evasions, I guess, that are literally truly instantiating new connections, but splitting the exploit payload across those truly separate connections. That would actually be an interesting question to try to figure out how possible is that to do for across the exploit set for Metasploit, for example.
And that's what got me thinking is if you try taking a conventional exploit, find something in memory somewhere, and then come back and execute it later.
Yeah.
It would have to put the file on disk or something somewhere.
Yeah,